So this project, and I'm going to write this so I can see it and then I'll flip it over, is a rocket motor test launch stand. Excuse my handwriting. So what we need to do is we need some kind of stand. I'm just going to do a quick drawing. So some kind of like tripod thing with a disc, so and a pole for a launch stand, just like a ST's rocket launch stand. But I need some kind of sensor here that can measure the amount of thrust, measure thrust. So when we build our rocket motors, we need to know how much thrust it's producing. So we can refine the mixture, refine the nozzle, and whatnot. So the requirements are, it needs to be safe. So to me, well, we need a module here that controls the, that records thrust and sends the voltage to the igniter to launch it, to actually ignite the motor. So ignite motor. So because we're working with high velocity motors, this has to be safe distance. From the person that's actually launching it. So what I'm planning on doing is using this chip right here, which is an ESP32. So ESP32, and that will record the data using strain gauges. So I'll have strain gauges connected to it, and it has a limited amount of memory, but we're doing short durations of burns within a few seconds, so I think the internal memory will be enough, but in the future I will want to save it to an SD card, so I should have that option. And I should be able to transmit data. So on this side, I'm going to use a TTG. I can't remember the company that makes it. Put it over here. So basically, it is ESP32 based with a display and SD card. So ESP32 has a built-in protocol for wireless connection of the two devices, up to 256 devices actually. So I'm going to use it's called ESP now, and I've read that the distance on that can be up to 1 kilometer. We'll have to see, but to be able to do countdown on this, when it reaches, when you start the countdown sequence, it will do the countdown. It has little speakers, so I can actually And I apologize for the camera shaking. It'll, when it reaches 0, it'll send the signal to here, which will activate a relay that's connected to the igniter and a 12-volt battery, and it will launch that. So, so that is the plan. Now, this chip I might have to replace because it has some issues with when you enable wireless, it wants to reboot, so it may have an internal issue. It may not be that one, it has some others too, so it may just be a quirky thing. I have 2 relays here that I can use to ignite. I have a military grade box, which is right here. That we're going to put all that in to sit here, and it actually has some cool looking switches on, so we'll get to that later. But this is the start of the project. The code for this side will be relatively simple. It's just a matter of starting the countdown from here. It'll run the countdown internally. Once it starts, it will record the data. Oh, first, actually start recording the data and then send the launch signal. The other thing I could probably do with it, and I'd have to do a little more research in, is enable some cameras. So that would be another possibility. I'd like to have as many cameras around the launch stand as possible without having to have somebody physically standing there. I guess I can record the data or view the data in real time in a graph on the screen, and I can put this in a nice little box. So that's the plan. I will get started on this shortly. I actually have some aluminum stand that I had started. It's actually pieces from a frame of a pop-up canopy. So it will be a tripod-like thing with some things on the end of the legs to stake it into the ground for stability and safety, and you'll be able to adjust the angle of the launch rod. More on that later, but this is a start, and I'm going to explain it to you, and we will work together as we build it.